Hi everyone, my name is Volodymyr Yartsev. I want to present my research about AI models for automatic objects classification in satellite images. Satellite imagery is essential for monitoring the environment, managing urban growth, and responding to disasters. Traditional segmentation methods often fail to handle the complexity and sheer volume of modern satellite data. Recent advances in deep learning, particularly CNNs and transformer-based models, have dramatically improved segmentation accuracy and scalability, enabling precise classification of rivers, forests, and buildings for a range of real-world applications. Object segmentation is satellite imagery delineates distinct classes, for example, water, vegetation, urban structures, for various practical applications. Practical applications, environmental monitoring, tracking deforestation, water level changes, and vegetation shifts, urban development, mapping urban growth, infrastructure planning, and land use classification, disaster response, rapid assessment of flood, wildfire, or earthquake affected areas. Traditional satellite image segmentation methods such as thresholding, edge detection, and classical machine learning techniques have been widely used in remote sensing applications. A comparison of traditional and AI-based segmentation methods. Thresholding is simple and computationally efficient, but limited to binary segmentation sensitive to noise. Edge detection is effective for boundary delineation, but struggles with complex landscapes and occlusions. Region-based methods are capture spatial relationships, but requires fine-tuned parameters, not scalable. Machine learning, more robust than traditional methods, but requires handcrafted features, limited contextual. Deep learning, like CNNs, UNet, Mask, are CNN. High accuracy, automatic feature extraction, but requires large datasets, computationally expensive. In the process of implementing the object segmentation system on satellite images, a comprehensive approach was applied, which begins with data preprocessing. Satellite images obtained from the platforms undergo a stage of normalization, color correction, and patching, accompanied by augmentation using rotation, scaling, and reflection. Next, a segmentation model is developed based on the UNet architecture using convolution neural networks supplemented by regularization using dropout and batch normalization, and optimized using loss functions such as dice loss or gross entropy loss. The model is trained on training, validation, and test samples with optimization using the Adam algorithm, while the GPU significantly speeds by the computational process. After the initial segmentation, additional classification of the selected segments is applied with subsequent post-processing for noise filtering and visualization of the results, which allows you to check the quality of the system. Semantic segmentation is used to identify land surface types from satellite images. The most basic use of the technology is to identify water body contours to provide more accurate cartographic information. Advanced algorithms are used to map roads, identify crop types, and so on. In the first example, UNet was used. This approach effectively supports landscape analysis and territorial mapping. The second example demonstrates the process of segmentation of a satellite image for the analysis of coastal ecosystem. This method of analysis allows for automatic classification of areas based on spectral characteristics, which is useful for monitoring the state of water bodies, identifying environmental problems, and planning environmental protection measures. The third figure is good example combination of AI with satellite data to access real-time disaster impacts like flood, wildfires, and hurricanes. During the experiments, four deep learning models were tested for both semantic and instance segmentation: UNet, DeepLab VTRAP 3 Mask R CNN, and Swin Transformer. The main metrics included IOU, dice coefficient, pixel accuracy, and MAP. Results were presented in tables and figures in my research. UNet provides a good balance of accuracy and speed, especially suitable for semantic segmentation tasks. DeepLab achieved the highest pixel accuracy but required longer training. Um, it excels and at large scale segmentation, like, for example, forests and farmland. Mask RCNN offered stronger instance level recognition but slightly lower IOU due to complex backgrounds and varying landscapes. Swing Transformer achieved the highest IOU, but dice uh, stove at a higher computational cost. Overall, Swing Transformer delivered the best accuracy but demanded more resources, whereas UNet remains the most balanced in terms of the accuracy speed resource trade off. This study examined AI-based segmentation of satellite images for classifying land cover types like rivers, forests, and buildings. Deep learning models, including CNNs and transformers, outperformed traditional methods in accuracy and robustness. Study confirmed that AI-driven models, especially deep convolution networks and transformers, can effectively classify objects in satellite images, significantly outperforming traditional methods or in terms of accuracy and scalability. Thank you for watching.